to domain-driven design, we have our speaker, Karynn Ikeda. Karynn is a lover of language, from ancient Latin to modern German to language we all use, Ruby. Now a staff engineer at Babelist, Karynn leverages semiotics within a Rails codebase to design systems that are easily read and self-explaining. So please put your hands together for Karynn.
Great, thank you so much. It's wonderful to be here. It's also my first time at RailsConf, so very excited to be joining you as a speaker today. So as she said, my name is Karynn, and I work as a staff engineer at Babelist. But I haven't always been a software engineer. As she said, I've been fascinated by language, and in college, I studied semiotics alongside linguistics and philosophy. And what is semiotics, might you ask? It's the study of signs and their use and interpretation. And I never really thought that semiotics had a practical use beyond academia until I became a software engineer. You see, one of our core jobs as software engineers is to be builders of sign systems. And what do I mean by a sign system? Well, natural language is the primary sign system that we use every day. We use natural language to communicate the thoughts in our head, just as I'm speaking to you now. And of course, as software engineers, we use programming languages like Ruby to express the behavior of our technical systems. And when I say that we are builders of sign systems, I mean that we are inventing our own language in a way. Every variable, every class is something that is created by developers and unique to the repos and applications that they occupy. And as builders of sign systems, I think it is especially important that we understand how signs work and allow us to design better systems. So what is a sign? So sign is composed of two parts, the signifier and the signified. And to make this a little bit more concrete, I want to present you with this art piece by Banksy that teases this relationship. So in this piece, we see a pipe jutting out from the frame and the message, "This is a pipe." It may seem fairly obvious, but the cursive lines for the word pipe is the signifier in this case, and what they are signifying, the signified, is the literal pipe jutting out from the frame. And together, the cursive and physical object form a sign so that when you see or hear the word pipe, that invokes the literal concept of a pipe. And relating this back to language, the letters for pipe are not the universal signifier of pipe. Here is pipe in a few different languages, right? They all should invoke the physical object of the pipe to speakers of these languages, right? And we can still make an assumption from that signs are invented, right? Each language came up with its own symbol or sign for pipe. And also brings us to kind of my first point about a name. Signs are arbitrary, right? They can be whatever you want. And if names can be whatever you want, what makes one name better than another? So my talk today is about the declared name, the signifier, and its place as a sign when invoked in an application. We have been told that naming is one of the hardest problems in computer science, and I believe that this is because in choosing and using a name, we are extending a sign system that we want to be understood by other humans. And we must understand how a name functions within the system to be able to use it. Let's look at the humble variable. Variable declaration and assignment started as a mechanism for the machine to know where to store a piece of data so that it could be read or overwritten later in the program. And we, the programmers in this case, are communicating with the machine. However, if variables are an abstraction for machine language, why do we even need meaningful names in our code bases? Does X not serve this purpose? And yes, If we were only communicating with the machine, we could stop here. But today we work on collaborative code bases, and our variable names need to communicate intent to other humans. A programming language serves two functions, communicating to the machine and to fellow programmers. And especially in an untyped language like Ruby, you don't have any guarantees about what is actually being signified. So names act as signs communicating what is signified to other humans. And it is the human piece that matters, right? The machine doesn't care that you've assigned 0 to X, but the human really does. And the variable X only makes sense if you know the context. You can actively see the variable assignment in the code, and so that the relationship between X, the signifier, and what it signifies is laid bare. But imagine your code read out of context. This happens all the time in Rails. For example, let's look at controller instance variables in the view. Rails copies controller instance variables to the view initializer. And what this feels like us to programmers is that this is semantically the same variable. And thus, when we see these variables in the view, we read them out of context. And we're relying on the strength of a variable's name to convey what is signified, since we can't see the variable declaration directly in the view class. So let's return to our example. Let's try to give this a more meaningful name. How is bit? Is this any better? Well, I've already said that names are arbitrary, so what makes bit a better name than X? I would argue that this is only a better name because we're drawing on a context outside of the actual code. We know that in English, a bit is defined as a unit of information expressed as either 0 or 1 in binary notation. So we're cheating here a little bit so I can make my next point. Names have no inherent meaning. They only derive meaning from difference to other names. So what do we mean by difference? Take these two names. What's the difference here? We've added an S to the end. What assumptions are you starting to make about bit and bits? So if you guess that one was a scalar and one was a collection, you would be correct, right? Pluralization instantly communicates a lot to us, both in natural language as well in the code. And Rails makes use of singular and plurals throughout its MVC framework, right, to derive standing naming conventions. So this is a very kind of comfortable place for us as Rails developers. What about this difference? The characters are the same, but now we've capitalized one, not the other. What are your assumptions about this type of difference? We know that if we use all caps conventionally, this is a constant in Ruby rather than a variable. And we can make some assumptions about like whether or not we expect the value to change or not. What about this difference? Now we've added question marks and punctuation in there. I think this actually conveys even a lot more because punctuation is only allowed in method names. And also conventionally, the question mark also indicates that we intend to return a Boolean value. So pluralization, capitalization, and punctuation have meaning in Ruby and Rails that is unique and separate from how we use these types of differences in natural language. And already we've started to generate a world of meaning with very little context, just very subtle differences. So let's take another look at X, right? This could be anything, but does it look different to you now? Even if we know nothing about X, can we make assumptions based on what we've just talked through? And can we use our knowledge of coding conventions to leverage our understanding? Another way that you can think about difference is a concept called binary opposition. So this is when two concepts cannot exist simultaneously because they are defined against each other. In binary notation, this is expressed as ones and zeros, on or off. In Ruby and other languages, we express this through Booleans, true and false. we can also define, right, these two constants as the exact opposite of one another. These signs are bound together. If I were to change stop to true, go would immediately become false. And this provides probably the smallest example of how meaning within a sign system is interdependent, right? These values are coupled. And with evolving sign systems, like a code base, we must also reconcile how the introduction of a new sign or name alters the meaning of existing signs. So here we've introduced slow. We've defined this as false class and true class. What does slow equal? In this example, we've retained the names, the signifiers. We've actually changed the values of what is signified for the third state to make sense. And we can easily do this. It may change how it functions in the code. And it's more flexible when you do this with values than with names, right? You want to actually be cautious with how you think about binary oppositions, because English gives us tools for creating a similar type of opposition in prefixes and suffixes: inaccessible, accessible, unavailable, available, fearless, and fear. And so names are not static as signs. What they signify will evolve as other names are added or removed from a system. And what happens if we eliminate differences? Luckily, in the global scope, a variable or method name cannot be reused without overriding its definition. Right? It can only mean one thing. However, names can still be reused when we consider different scopes, which brings us to the class. So let's take another look at the Banksy piece. His piece is actually referring to an earlier work by René Magritte, and the message here beneath this pipe is translated to "this is not a pipe." We see here that the name pipe can be used to signify both a plumbing pipe and a smoking pipe. And within the context of each art piece, this is internally consistent, but when compared between these two art pieces, the semantic meaning becomes less clear. And classes act as a similar type of frame on our code. When attributes and methods are private, we only have to worry about the semantic relationships within the class. Right? Here we have a wheel for steering and tires for motion. However, when attributes and methods are public, we must consider the semantic interactions between different objects. In this case, we also have a unicycle, and that has a wheel. Is the car wheel the same as the unicycle wheel? And unlike art, we can't easily see what's inside the frame. We can't know if wheel signifies the same concept without looking inside of the unicycle class. In this case, the unicycle's wheel is more similar to the car's tires and the handle to the car's wheel. And when the same signifiers are used alongside one another but signify different concepts, it creates cognitive dissonance. This makes it more difficult to understand and comprehend the code, since we need to keep track of which wheel is used for steering and which wheel is used to move the vehicle across the ground. So names as signifiers can be identical, but signify different concepts, and this can sometimes create cognitive dissonance within the sign system. However, difference is not always bad, right? As long as it's signifying the same concept, we're okay, and we actually leverage this through duck typing, right? If Go is conveying a similar concept, even if it's implemented slightly differently between classes, we actually use this to create more cognitive similarity between the classes. Coming back to the artwork, let's take another look at these, right? Before, we were looking at the signs of the pipe within each frame and comparing them. But both of these pieces of art are also signs themselves, right? They're signifying the act of signification and drawing relations, right, to the rest of the art world as art pieces. And so signs are not one-dimensional. signs can contain signs. Another example of this are compound words in English. Automobile, taken literally, the words auto and mobile translate into self-moving. But we also know the automobile as a vehicle with four wheels. So even though it contains signs, it is now its own sign, distinct from its parts. So classes encapsulate our variable and method names, but are their own distinct signs. And just as we saw with the variables, the introduction of new named classes will alter the existing names signified. Relationships between higher level signs like classes matter just as much as lower level signs like variables and methods. So let's imagine that we are Victorian developers. Here is a semantic model for a Victorian vehicle. It has wheels, it has a chassis, body, and horses. So now we introduce the horseless carriage. How does this actually change the way our signs relate? At first, it doesn't actually seem like much has changed. We can accommodate this new concept fairly easily. It shares many of the same attributes as a carriage. We could even create a very handy method to tell what is a carriage and what is a horseless carriage by asking ourselves if it has horses or not. But it also has this other thing that the carriage doesn't have. It has an engine. Not sure what to do with that right now. So we could leave this exactly as is, right? Keep our model of the world almost exactly as it was before we introduced the horseless carriage. But I want to kind of flip this on its head, because a horseless carriage can only be something that does not contain horses but contains an engine. What if we want to introduce buses or cars or different types of moving objects and vehicles? We'd have to really rethink our decision to use the word horseless carriage. And in fact, the horseless carriage was another name for the automobile. We transitioned to the automobile. And in doing that, we didn't just change the name of horseless carriage, we also sort of recontextualized what a horse was. So in the previous example, we had horses. In this example, we're actually relating horse to the concept of engine. And this is really important because engines today are defined in horsepower. And so this actually has become another semantic term for how we think about engines and how we actually think of horses as a unit of power and not just an animal. So think about how many horses and horseless carriages you still might have in your code base. So we've talked about some strategies for organizing our sign systems using classes. However, as code bases grow bigger, are classes enough? Do we want to apply any of our other semantic learnings higher up? As code bases grow, there's a need to break them up into smaller components to manage complexity. We've seen this over the last decade with microservices containing business logic in smaller repos, so individual teams can own them. And again, the computer doesn't really care how we organize our files so long as it can find them. This is largely a human problem in scaling how code is worked on as engineering orgs grow bigger. Right? We need an organizational level to understand what code goes together so that we can assign owners, break down tasks. And another concept that gains a lot of traction within the Ruby on Rails community is also the idea of the modular monolith, which I'll talk about. Rails gives us organizing principles based on the model view controller design pattern. This is a function-based approach, organizational approach. And Rails, right, is not really opinionated how we might use another concept from Ruby around namespace, right? Within classes, we can also create a framework of organization. However, within this MVC model, we don't have a holistic view of everything that relates to a namespace like manufacturing, right? It's split across different hierarchies in our directory structure. Instead of one frame, we end up with multiple frames. And lucky for us, there are a lot of tools now that help us organize our code, starting with the PACS modularization tool chain. So the idea with the PACS standard is that each PAC represents a modularized domain, a package, and we can describe that package using other tools like PACWork and constrain that package graph or define dependencies. And we can even make this work better with Rails to actually get a hierarchy that makes sense when we want to group classes and files together into one view. So instead of having your namespace buried in each models, views, and controllers directory, with packed Rails, you can invert this and place your package name closer to the root. And now you can see all of your code in the context of that MVC model, right, displayed neatly in one clear directory hierarchy. But to do this, you really have to ask yourself, what makes for a good package? Right? Robert Martin has some well-respected guidelines that are built around the idea of strong functional cohesion. So this looks at the function of code and says that we should group classes together that are likely to be reused together, or if we add a feature, these are the classes that would likely change together. And on the flip side, don't group code that is not functionally related. And I think all of that makes a lot of sense. So Shopify was the creator of PACWork, and they were one of its earliest adopters in this idea of a modular monolith. They put out a retrospective earlier this year that I thought was really interesting. So developers tend to group code into packages based strongly on semantic clues that in many cases have little relation to how the code actually runs. Right? So we've completely gone against Martin's principles of group code by function. Right? We actually decided to group these semantically. And this makes a lot of sense from the semantic perspective. Right? You're more likely to group similar sounding classes together because that's how you achieve difference. Right? And we've already established that when we violate this concept of difference, it creates cognitive dissonance. And so if I'm going to take two files with manufacturing name and split them up, I have to start asking myself the question of well, what does manufacturing even represent? And so you have this idea of functional coupling and semantic coupling. And I think there's a really interesting tension between these two, right? Because they don't actually always go together. And in fact, we actually need to make hard decisions about which one we want to prioritize. In the Shopify case, they decided to deal with the functional coupling and set aside the semantic coupling for another day. And I think that we as software engineers notice this, but we may not always see semantic debt as a form of technical debt, right? Semantic issues usually don't arise through coding shortcuts, but an evolution of a system over time as we're adding new names, new classes, new variables, and we're not actively aware that the sign system itself is evolving. And renaming can be incredibly expensive. So this is not a recommendation for you to go out and rename all your files and your classes, but more an observation about how these contradictions arise in our code bases. And you have to treat this like any other type of technical debt. How do you want to prioritize it? Because there is a cost, right? It will take new hires longer to onboard to your code base and navigate these semantic contradictions. And bugs may be introduced, right, through misinterpreting how a particular piece of code functions because of its name. Is there a better way? Well, most of us work on systems that mirror the real world in some way. Modeling our code on names used in the real world can be a strategy for staying ahead of semantic issues, since business domains are usually slower to change than our code bases. And this is the hallmark of domain-driven design. which matches the design of our software to our understanding of the real-world business domain. And domain-driven design starts first with language, anchored in semantics, and observes how the language is used outside of the code, and then embedding these names into the software system. And domain-driven design refers to this as the ubiquitous language. When we model our signs after the real world, we have to do less heavy semantic lifting, since we'll also inherit the associations of how these names relate in the real world. And internally, when we communicate with different stakeholders, we can speak one language, which also facilitates discussions over how this system should evolve and creates shared understanding. And this is all well and good with established business domains, but we work in a field of innovation, and the code we write may actually lead to the creations of new domains. Think of social media, right? That didn't exist. That didn't have a counterpart in the real world. So how do we choose names in this context? I want you to ponder the power of metaphor. We are here in Detroit, which is the home of the first mass-produced automobile. And alongside that, incredible use of a concept called the assembly line. But Henry Ford did not invent the assembly line. He borrowed the domain and its concepts and ideas from the meatpacking industry. So Ford's innovation was reimagining how the assembly line could be applied to automobile manufacturing rather than inventing the idea itself. And this is where I think the metaphor is really useful. So you see, in meatpacking, butchers would cut away parts from the animal as it moved down the line. They would take things away. And Ford actually imagined this in reverse. So instead of taking away parts, you would add parts. It's not a direct translation, but there's enough similarities, right, that you can start to see how you might design a system based on language used in another industry. And so positionally, the completed car occupies the same space as the animal's body, right? Similar to our horse and combustible engine. And this brings us to our final lesson for today, that names help you frame a problem and create a framework for talking about systems. Because remember, we are not presenting our fellow humans with a glossary or dictionary of terms, but a system of signs. And if we understand a name's place within that system, we can all collaborate together to make better systems. I want to leave you Great. I want to leave you with one final pipe. When the Unix creators were trying to convey how to take the output of one function and feed it in as the input of the next function, they also turned to metaphor. And this shortcuts our understanding of what the symbol signifies and how it is used. And it is a classic example of an enduring name that still imparts meaning today. Thank you.